Here we have a direct current RL circuit. Don't want to confuse this with an alternating current circuit. So we're going to be using the formulas for our formula sheet for an RL circuit. For example, the voltage drop across the inductor at any given time is equal to the maximum voltage drop times e to the minus t over tau, right? Where at t equals 0, that voltage drop across the inductor is equal to its maximum possible value, which is the EMF of the battery. Because at t equals 0, this exponent is equal to 0, and so the exponential term is 1. That's the biggest it can ever get. So that's 12 volts. So there's our answer to part A. Okay, now part B, at what time is that voltage equal to 2 volts? Well, let me elaborate on this a little bit. At t equals 0, the current is changing fastest. Right, that's when the rate of change of the current is largest. Delta I over delta t is maximized. And remember that the voltage drop across the inductor is proportional to delta I over delta t. And so that means both must be maximized. All right? Okay, so for part B, now this is just sort of straightforward algebra. We set the voltage drop across the inductor equal to the max. Okay, now tau in this case is L over R, and we're given both of those. L is 0.045 henries, and the resistance is 3.5 ohms, so that's 0.01286. So we'll save that. All right, so this is 1/6 is equal to e to the minus t over tau. So I take the natural log of both sides, and I get negative 1.792 is negative t over 0.01286. So that gives me a time of 0.023 seconds. So that's about 2 tau. And that makes sense. The current has dropped by about 85% or so at this point, from 12 down to 2 after 2 time constants, so that makes sense. All right, part C. Now when the current is 2 amps, what's the voltage drop across the inductor? Well, if I equals 2 amps, then the voltage drop across the resistor is 2 times 3.5, which is 7 volts. Now the loop rule says that the EMF is equal to the voltage drop across the inductor plus the voltage drop across the resistor. So the EMF is 12, and the voltage drop across the resistor is 7, so the voltage drop across the inductor at that time must be 5 volts.